Hello, everyone. In this session, we are going to talk about generative AI document summarization on Google Cloud. My name is Zhuo. I'm a Google Cloud Senior Practice Lead at Deloitte and a Deloitte Certified Chief Architect. Here is the agenda. We are going to start with the problem statement, and then I will present you a high-level solution with the reference architecture and the design patterns. After that, I'm going to talk about an interesting situation in that large languages are constantly evolving. And how can we leverage tools that seamlessly integrate with the latest LLM advancements? At the end, I'm going to do a demo. And before the demo, I'm going to have a Q&A session. All right, let's get started. In generative AI world, large language models have become a key AI capabilities for automations like document summarization. And it can significantly reduce human effort and processing time. But how does an elegant document summarization AI architecture look like? And since large language model constantly evolving, how can we design applications and leverage tools that seamlessly integrate with the latest LLM advancements, ensuring we leveraging the most up-to-date capabilities without requiring much effort? Last, how do advancement in LLM capabilities influence the architecture design? Here's the high-level solution. And I'm going to walk you through a reference architecture from the runtime perspective. Let's say people upload a PDF file directly to the cloud storage bucket. This upload triggers event arc to begin the document processing phase. And this document processing phase is handled by Cloud Function. Cloud Function played a role as orchestrator. And it uses Cloud Vision AI to extract all the text from the PDF file and stores the extracted text into the cloud storage bucket. And then Cloud Function use Vertex AI large language model to summarize the extracted text. At the end, it stores the textual summarization of the PDF files inside a BigQuery table. And if we look at it from the components perspective, each component serves their purpose in this reference architecture. Cloud storage stores the PDF documents and extracts the text. Event arc watches for new documents in the cloud storage bucket and triggers an event in Cloud Function. And the Cloud Function orchestrates the document processing steps. And the Cloud Vision AI extracts the text from the PDF documents using the optical character recognition, which is also called OCR. And Vertex AI large language model creates a summary from the extracted text stored in the cloud storage. And BigQuery handles the storage of the generated summary. So this table listed this reference architecture components. What are these components? And what's the purpose in this architecture? And I'm not going to read through the slides. You are feel free to read it after the presentation. And this reference architecture is based on-demand data processing design pattern. And you can see when a file arrives at cloud storage, a cloud event will be created and handled by event arc. A cloud function is triggered to process the event. It is extremely suitable for event-based applications and data transformation. And cloud function is bind to triggers automatically on event. And it is an abstraction layer of Cloud Run, can auto scale down to 0. So there's no pre-provisioning, only pay for what you use. Cloud Function also supports all popular languages from Python, Java, Node.js to Go, PHP, Ruby, and .NET. And Cloud Function played a role as an orchestrator, and it used Cloud Vision AI to extract all text from the PDF file and stores extracted text inside a cloud storage bucket. Use Vertex AI large language model to summarize extracted text. And at the end, saves the textual summaries of the PDF files into the BigQuery table. And since large language models are constantly evolving, so how can we leverage tools that seamlessly integrate with the latest LLM advancements, ensuring we leverage the most up-to-date capabilities without requiring much effort? Here's what I did. Now, actually, if you look at this screenshot, you will see this application is using Text Bison PaLM API. But Gemini Pro is already here. It will replace PaLM API. And how can we do a migration? And here's what I did is that I leverage on Vertex AI Studio. And I put the scientific paper here and tell the large language model to summarize this article for me. And I specified the Gemini 1.0 Pro as my large language model with the parameter settings here. And you can see it can summarize this article for me in the response. Certainly, AI Studio is not only just to give you the experiment, but also can give you the code. And I use this code to migrate from PaLM API to Gemini API. Gemini also is able to help you to finish some code if you give it a prompt. And if I use Gemini 1.5 Pro, which supports multimodality, this reference architecture can be further simplified. Let's take a look. First of all, I upload a PDF file directly to the cloud storage bucket. This upload triggers event arc to begin the document processing phase. Nothing changed. And then the event arc send this event to Cloud Function, and the Cloud Function played a role as the orchestrator and started the document processing phase. But what it changed is that the Cloud Function is no longer use Cloud Vision AI to extract the text from the PDF file. And certainly there's no extracted text that need to be put into the GCS bucket. Instead, the Cloud Function use Vertex AI large language model to summarize the text in the PDF document. And Cloud Function stores the textual summarization of PDF files inside BigQuery table. So you can see originally there are 6 steps to do the document processing. Now it's down to 4 because the innovation of Gemini 1.5 new capability are multimodality. And this reference architecture is significantly simplified. Here's the conclusion. Today, we talked about 3 things. We dived into the architecture design. We explored a reference architecture for AI document summarization on Google Cloud, leveraging generative AI for efficient and insightful summaries. Second, we talked about how to handle constantly evolved large language models. Effortless LLM upgrades can be achieved through AI Studio's experiment and code generation capabilities, and with ensuring application harness the latest advancements. Third, evolving large language models impact architecture design. With new LLM functionalities, for example, multimodality, reference architecture can be further optimized for future applications. Let's refresh our memory on what I'm going to demonstrate about this reference architecture. I'm going to walk you through each components and in my demo. And remember, cloud storage stores the PDF file documents and extract text. And the event arc watches for new documents in the cloud storage bucket and triggers an event in cloud function. And the cloud function orchestrates the document processing steps. And the Cloud Vision AI extracts the text from the PDF document using OCR. And the Vertex AI large language model creates a summary from the extracted text stored in the cloud storage. And BigQuery handles the storage of the generated summary. All right, let me switch to a different window and show you the demo. In this demo, I'm going to, first of all, use GSUtil to replicate a document into GCS bucket. And here is the GCS bucket upload folder. Is stores the uploaded document. This is the second scientific paper I'm going to upload into this GCS bucket. Now we have 2 PDF files. And end results is summarization has been put into the BigQuery summary table. That's the end result. And here is the event arc I want to show you. Once the document has been uploaded into the GCS bucket, it triggers this event. And event arc behind the scenes also create pub sub. This is the pub sub topic, and this is pub sub subscription to ensure it can handle exception and failing scenario. So event will not be dropped. And in cloud function, you can see this is the second generation cloud function based on the cloud run. And here's the main entry point, main.python file. And in this cloud function, we also set up quite a lot of runtime environment variables. For example, project ID, location, and dataset ID, table ID, and output bucket, and etc. It runs on HTTPS protocol. And if we take a look at summarization by large language model application log, we will see the step-by-step. When we upload the document and it will trigger an event, and this event will send into Cloud function, and the Cloud function will orchestrate the document processing flow. First of all, it invoke Vision AI to do OCR to extract the content from the PDF file. And then the extracted content was put into a GCS bucket. And after that, Cloud function invokes large language model to do the summarization. And the summarized results is put into GCS bucket. And at the end, the content, the summary is put into BigQuery table. When I upload the second document, it is doing exactly the same thing. This whole process is repeated again. And here is the service account I created, and with the necessary roles assigned into it. And if we look at here, this main Python file is using text Python Palm API. And since I'm going to change it to use Gemini API, what I did is that, first of all, I put it into this content of the scientific paper into Vertex AI Studio. And I tell, here's the prompt, please summarize this article for me. And you see, here's the summarization in the response. You can see I'm using Gemini 1.0 for this experiment. And furthermore, AI Studio will also generate the code for me. And I'm going to leverage this code to migrate my Palm API into Gemini API. And here again, if I do this experiment again, I upload these two documents. And you can see the document has one being extracted into a text file and put into GCS bucket. And after that, the end results is a summarization has been put into the summary table. That's the end results. So nothing changed, but you see the code I have changed into from Palm API, text Python to Gemini 1.0 with all the necessary parameter. Furthermore, if you see this Python file, I even put safety settings for Gemini 1.0 and generation configurations to use Gemini API. If I run the results, you can see when I upload the document, and the document will be summarized into put into the BigQuery table. And all the steps are exactly like the previous, as what I showed you. Nothing changed, although I swapped from Palm API to Gemini 1.0. If I want to do further, I can leverage on Gemini 1.5 to summarize this PDF file for me. And you can see here's the response, here's the summarization, although it is a little bit verbose. And I can further leverage on the AI Studio generated Python code to do the migration. All right, this will conclude our demonstration.